Hi guys, this is the second video from the same lesson, so I will try to upload it at the same spot once I figure out how to do that. We will be dealing with multiplying monomials, okay? To do that, we will be using something called product rule. And here we go. This is the product rule. That's how it says, product rule. And this is actually my product rule. X to the a power times x to the b power equals x to the power a plus b. Now I'm going to explain you something. Let me write down. I'm recording and writing stuff down. Okay, for example, if you had 2 to the third power and you multiply it to the 2 to the fourth power, okay? So what actually would happen? 2 to the third power is 2 times 2 times 2, okay? So that's what it is. Times 2 to the fourth power is 2 times 2 times 2 times 2, correct? Correct. I know you cannot answer. So once I start multiplying them all together, what will I get? 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64, times 2 is 128. Okay, so now I want you to count how many 2's you see right now. 1, 2, 3, 4, 5, 6, 7. So I multiplied 2 by itself 7 times. So what it is 2 to the 7th power, correct? I know you cannot answer. I'm just used to asking you questions. So what it is 2 to the third power times 2 to the fourth power. Turns out that it's 2 to the 7th power. Okay, so if this is true, then 2 to the 7th power has to be 128. So let's figure it out. Let's figure out. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2 is 128. So that's correct. 2 to the 7th power is 138. We just proved 128. I'm sorry. So we just proved this rule. This is a product rule. So really, when we multiply 2 to the third power times 2 to the fourth power, we have to add exponents together. So it's actually 3 plus 4. And then it equals 7, 2 to the 7th power. So if we had 2 to the power a times 2 to the power b, the answer would be 2 to the power a plus b. It was easy to add 3 and 4 together and we got 7. Here we cannot add a and b together, so we just leave it alone like this. So imagine if we had x to the a power and then we would have to multiply it by x to the b power. We would do the same thing. We would leave the x on the bottom, right? This is our base. And we would just add the exponents, a plus b. So here we go, the formula. I just derived you the formula. I just explained you how it works. So I always make sure that I show you how we get the formula instead of just giving you the formula. Okay, so things have to make sense. Now we're going to go using this rule. We're going to go over the problems on your worksheet, on the back of that first worksheet. So we see at number 17, we see x squared times x to the third power. What do we have to do? We have to add 2 and 3 together to get 5. Okay, so when we multiply exponents with the same bases, x is our base, and you learned it previously. X is our base. We're going to put the base down, and then we're going to add the exponent. So when we multiply, we add exponents. The second problem number 18. A to the 10th power. A to the 9th power times a. A even though it doesn't have the exponent, we know that it's a to the first power. When we multiply exponents with the same basis, we add the exponents. We add the powers. 9 plus 1 is 10. So it's a to the 10th power. Number 20, it's a little bit more involving. In addition to exponents, we do have coefficients in front of those exponents. So to deal with coefficient, we are multiplying coefficients, correct? We see 4 times 3. That's what we're going to do. We're going to multiply 4 and 3 together. So 4 times 3 is 12. And then we're multiplying x squared times x to the 5th power. When we're multiplying exponents, again, we're adding our powers. 2 plus 5 is 7. So that's how we got this answer. Here, on top of exponents, on top of coefficients, we have a negative coefficient, but we see that we are multiplying everything. It's multiplication, right? So we're multiplying monomials again. Negative 4 times 3 is negative 12. Why am I multiplying? Because I'm dealing with coefficients. The numbers in front of the variables are called coefficients, and we are multiplying them. So now we have a to the 3rd power, and we have to multiply it by a to the 2nd power. Again, we have to add those powers together. 3 plus 2 is 5. The same thing will happen with the b. b to the 1st power and b to the 5th power. Multiplied together is b to the 6th power, because 1 on top here and 5 on top here have to be added together. Even though you see this negative right here, we're not subtracting, because we do see the multiplication. That dot means multiplication. So basically, we're multiplying everything. We have to multiply coefficients first. So 2 times negative 5 is negative 10. Negative 10 times 3 is negative 30. That's how we got the negative 30 here. And then we have to multiply our exponents. Y to the 1st power, y to the 2nd, and y to the 3rd. 1 plus 2 plus 3 is 6. So it's y to the 6th power. Problem number 29. So we see coefficients 6 and 7. We multiply them together. It's 42. M to the 1st power, m to the 2nd. Multiplied together will give me m to the 3rd power, because 1 plus 2 is 3. And then n times n to the 4th power is n to the 5th power, because 1 plus 4 is 5. Number 32. Well, on top of negative coefficient, we have to deal with the fraction. So it's negative 6 times half. What is half of negative 6? Half of negative 6 is negative 3. Now we have to deal with we have to multiply a to the 2nd power times a. It's going to give me a to the 3rd power. B times b is b squared. So you're on your own. Problems 21, 22, 24, 25, 27, 28, 30, 31, 33, and 34. And I'm just going to explain you 35 and 37, and then you will also try 36 and 38 as the classwork. Even though we're not in class, I need you to submit it to me. So here we see the addition. So we will have to add. But before we add, we have to multiply, right? Multiplication happens before addition. So we're multiplying this and this together. So 2 times 4 is 8. X to the 5th power times x is x to the 6th, because 5 plus 1 is 6. Y squared times y to the 3rd power is y to the 5th power. Now, here we see 1, here we see 3. Even though we don't see 1, we know that it's 1. 1 times 3 is 3. Sorry, I'm just tired of holding this phone. X to the 4th power times x to the 2nd power is x to the 6th power, because 4 plus 2 is 6. Y to the 4th times y is y to the 5th. And then we discover that once we multiply those two monomials together, in the end, we do see the like terms. And I see it I made that conclusion by just looking. I see x to the 6th power y to the 5th, x to the 6th power y to the 5th. So they're like terms. 8 plus 3 is 11. 11 what? 11 x to the 6th power y to the 5th power. Again, this part does not change. When we add 8 of those and 3 of those, it's 11 of those, okay? Now I'm going to go over number 37, and then you're on your own with your classwork and the homework. And I do want you to post it to me by, the classwork should be done by Tuesday night, and the homework should be posted. Let me give you till Wednesday night to do that. So here we see that we're subtracting. But here we see that we can multiply some things, some numbers, right? So 4 times 3 is 12. Negative is left alone. M to the 5th power times M to the 3rd power is M to the 8th power. N times N to the 7th is N to the 8th. We see that we're dealing with the same like terms, so they're like terms. 19 minus 12 is 7. And then we're just going to copy our variables. Let me know if you have any questions. Again, this is the second video. And I'm going to post 2 videos for this lesson. Again, your classwork is due by Tuesday night, and your homework is due by Wednesday night. And I do want you to write all these problems, all the solutions that mentioned in both videos as well. Okay. I want you to make a picture of your worksheet and send it to me by Google Classroom. I hope you will figure out how to do that. And I hope that I'll figure out how to upload those videos as well. Okay. Have a good night, guys. Bye.